So, in this video we will talk about Kaldi and Kaldi from the beginning, and we will also talk about how to install Kaldi and how to run a small demo speech recognition project in Kaldi. As I said, we will talk about how to install Kaldi, especially for Linux based environment, and what are the Kaldi requirements. Some there are some pre-packages which should be installed in the Linux environment in order to install Kaldi, and there are also some other requirements, programming requirements such as bash programming, Perl scripting, and Python and C++. But most of the time uh, we will be using only the bash programming because the Kaldi core is built in C++, and there are also some wrappers for Python. So, for the time being we will focus on bash programming. Okay, so we have to be prepared for an environment for Kaldi in Linux. So, there are some software components which needs to be installed in the Kaldi environment, such as awk, which is a programming language, and it is used for finding patterns and searching for the files. Another one is bash, which is very familiar in Linux, and it is used for scripting languages. Grep, we will also use grep command, which is a utility for searching and finding regular expression in the files. And Mac is usually used for building binaries for Kaldi in Linux, and Perl is also a uh, programming language which is used for text processing. So, we should need these software in order to install Kaldi and run Kaldi successfully. So, first of all, how can we install Kaldi? So, the Kaldi repo is available here, and I think it must be noted that we should also have git installed in Kaldi environment. So, so first use the git clone command to download the Kaldi, and then go to the Kaldi main directory, and you will see some directories such as tools, source, and eggs and extra. But if you cat install in the Kaldi main directory, you will see some helps how to install the tools, the Kaldi tools in Kaldi. So, first you should cat install in Kaldi, in main Kaldi, and you will see some install is a text file. So, you will see some commands which should be run uh, in order to install the tools and the source directory. So, uh, if we go to the tools directory and then cat install, we will also see some commands which is used for running the tools, Kaldi tools in installation. So, first use the cat tool install command, and you will see commands which needs to be run, and it must be noted that it takes some time to install Kaldi tools, and once it's done you will see a successful message in the Linux. And then go to the cat source install command, and run the commands one by one. So, it will take some while. Feel free to take some rest and watch the Kaldi installation. So, as I said, Kaldis have some directories, which is source directory, where the Kaldi source code is available, and some tools the tools directory, which contains some component and external libraries for running Kaldi successfully. And there is also one directory miscellaneous, which contains different kinds of tools and other supporting and additional tools for running successfully, for running Kaldi successfully. There comes X directory, which is examples directory, and it contains nearly almost 30 speech recognition recipe uh, with the fully documented and bash scripts available. So, these are the directory structure of the Kaldi. Okay. So, next, now we want to create our own recipe for Kaldi using a very small tiny uh, data set. So, first create a project in the X directory, and then in the project create an audio directory, and then a data directory. Uh, once the audio and data directory is created, then create a train and test directory in the data directory. Once these are done, then the next step is uh, go to the train directory. In the train directory, we have some Kaldi formatting style files, which needs to be generated. So, the first one is web.scp file, which contains the utterance ID of the audio and the full path to the audio. Uh, an example is given here. So, here is the utterance ID, and the next one is the full path. It can be absolute, it can be relative path, but you can also use full path. So, the first column is utterance ID, and the second column is the full path or relative path to the audio. Then the text file should contains the utterance ID. Utterance ID is the same as in the web file, the first column. So, the text file contains utterance ID and the corresponding text transcription. So, as you can see, it is the utterance ID, and this is the corresponding uh, text transcription in the second column. Okay, so we generated two files. Next is the utterance to SPK file. The utterance to SPK file is as the name as we can learn from the name. So, it contains the utterance with the corresponding speaker. So, it contains the utterance ID and the corresponding speaker ID. So, again it must be noted that the utterance ID in the utterance to SPK file, the text file and the wave file should be same. Okay. So, in this utterance to SPK file, the first column is utterance ID and the second column is the speaker ID or speaker name. Then comes the speaker to gender file. So, it is it contains the speaker ID in the first column, and in the second column it should highlight whether the speaker is male or female. So, the speaker ID and its corresponding gender. Okay. Then comes the next file is speaker to utterance. So, the speaker to utterance file contains in the first column the speaker ID and in the second column utterance ID. So, it must be noted that this file does not need to be hand crafted, because there is a tool in the utility, and uh, it automatically converts the uh, utterance to speaker file into speaker to utterance files. We will talk about this, but it's not like it should not be manually created. Okay, so these were for the training directory. So in the training directory, we should have at least, there are also many more files, but these are like the minimum requirements for running a speech recognition demo. So we should have WAV file, the text file, the utterance to ID, speaker to gender, and the speaker to utterance should be generated on the fly. Okay, so the other important dictionary, the other important directory is the dictionary directory. So as you can see the first line, so create a directory in Kaldi with inside the data local directory, create a directory, uh, and in this directory we should have the lexicon text file. Lexicon contains in the first column, it is the word, the individual word, and it corresponding phonemes. So as you can see, for example, for word 8 there are two phonemes a, t, and similarly for 5 there are 3 phonemes. So in general, lexicon contains words with corresponding phonemes. Okay, so we have to create this file. Then comes the non silence phones file. So this file contains the phonemes or phones used in the lexicon, as you can see here. So these are the right side phones, and these are non silence phones. Then comes the next part is silence phones, which contains SIL, which is used for silence, and SPN, which is used for spoken noise. So these phones must be there in the silence phones file, and the optional silence phones contain silence phones. So these two files are pretty static, but the main components are lexicon and non silence phones, which contains the words with corresponding phones, and then the non silent phones in this file. Okay, so this is a little about lexicon directory. uh, so in the dictionary directory, we have to have 4 files. For example, lexicon, non silent phones, silence phones, and optional silence phones. Okay, so once this is prepared, then comes the language model part, and the language model, the language is actually the text used in this, it is the text of the training data. So as we have seen in the first path, uh, I will show you. This is the text file. So the text file contains the utterance ID and the text transcription. So in the corpus, we will have only the text transcription. So we will have to copy or we need the we will remove the first column from the text, and the remaining are the corpus. So, the corpus contains the text transcription in the training data. For example, 1 2 3 1 2 5 6 8 3 4 4 2 and so on. This okay. So, we will talk about language part later. Then comes the to file, which is quite standard. So, if we want to run our Kaldi project on local machine, then we use run.pl in the train and decode command, and if we want to use Kaldi in the cluster machine on a server, then we have to use some q.pl command, which is not important here, but keep here as simple as possible to use run.pl command. And then comes the path directory. So, these are some of the paths, relative paths where Kaldi searches for, but if you run the Kaldi in the local machine, then we don't need to change these. Okay. Then comes the run script, which is the main script for running the Kaldi experiments. And in the run scripts, the first three lines are very static. They are used for Kaldi settings, and then comes the number of jobs, which in our case we keep it as 1, and the language model order we keep it 1. So, it means unigram language model. Then the next commands are not important, but let's comes to okay. So, let's comes to this command, the last two commands, which is as I mentioned, these are used for generating speaker to utterance files. So, uh, we can generate this file using the following utils command in the training directory and in the test directory. Then this command is also validate command is also important for different kinds of fixing different kinds of sorting or other kinds of errors in the training or in the test directory beforehand. So, if we use these commands, they will tell you whether our data preparation process is good or not good. But this is a very good step to use, because it will indicate an error if there is some bugs in our data preparation process, and catching this before is very important. Okay. So, once the training directory and the test directory is prepared, next is the time for making MFCC features for the speech recognition. So, as we know that MFCC are very well known features for extracting speech for speech recognition and speaker recognition and many more speech recognition work. So, this command is used, the make MFCC command is used to extract features from the training data and the test data, and then the compute CMV instead is used to compute the capstone mean normalization. So, it uh, normalize the training data. Then comes the dictionary directory, which contains lexicon, non-silence phones, silence phones, and optional silence phones. So, these as I mentioned, these are part of the lexicon directory or dictionary directory, and we have prepared this beforehand. So, once these are available, we have to create a lang directory using the following prepare lang command. So, data slash local slash dect is already we have generated, which contains the above four files, and unc is an unknown phone which is used for unknown phones, and it will generate data slash lang directory. Okay. So, next is we want to build the language model part, and the language model part is we have already the corpus, right. So, for the language model, this n-gram count command is used to compute the n-gram of the language model. So, for example, we keep the order as is it is a very simple case. So, we keep the order as 1, and we use the data slash local corpus transcript in the as a input, and the output is a alpha formatted language model. Okay, and then this language model is converted to the FST format using alpha to FST command, as shown in the last the last command shows alpha to FST. So, this language model is converted to the FST format. Okay, so once we are done the previous steps, then the next step is to train a speech recognition using the train mono command, which is which is a a simple command, and this command is used for training a HMM based speech recognition. So, this is the very simple this command is for a very simple speech recognition, and using some statistical methods such as HMM and Gaussian mixture model. Once this model is generated, then we use then we make a computation graph using the model and the length, and build a computation graph, and then test data is used to decode the computation graph and compute the word error rate, which is used for evaluating the performance of the speech recognition model. So, the last command will show you will decode the computation graph using the test data, and we can evaluate our speech recognition model. Okay. So, as we know that using the above commands, they generate different kinds of directory. So, these are also important because running every command will generate some directories, and it should generate. So, the final the X directory, which is an experiment directory, they should contain some mono folder and graph folder inside mono, and then the decode directory inside mono, and the feature directory is contains computing the features of the and some extra. So, these are some directories generated, and these are some helpful materials for beginning and studying Kaldi. Okay, so if we have to summarize, so in summary we should have the training directory and also the test directory. The training directory and the test directory is the same, except they have different kind of data. So in the training directory we should have wave file, text file, utterance to speaker, speaker to gender, and speaker to utterance. And in the dictionary directory we should have lexicon, non-silence phones, silence phones, optional silence phone. And in the lang directory we should have lexicon fst, which contains the input is phones and the output is uh, words, and the grammar, which contains the input is the grammar and the output is the grammar, and the exp directory, which contains different kinds of experiments with the Kaldi. So I hope you have learned a little bit about Kaldi, and it is worth mentioning that all credit goes to this article, which is written for Kaldi for Dummies. So thank you very much. We will in the next video we will give a short demo how to run a Kaldi uh, using custom data in the from the beginning. Okay, thank you.